Good morning, everyone. Today I want to give a tutorial on RCD, which is the short form of residual current device. Residual current device, or RCD, is a device to protect human beings from electrocution. Before we study about RCD, first we will see the principle of protection from electrocution in general. You can see this is the circuit layout of a circuit uh, that is protected. For example, this is the house where I am staying, and this is a device which I am using, like heater or any other device. And basically, the supply comes from the supply company's transformer. Here you can see the supply transformer, and you can see the phase wire coming inside the house through the fuse, and it goes to the device, and the output is the neutral, which goes back to the supply transformer, thus forming a circuit. uh, Under normal condition, the current will flow from the phase wire. You can see here, from the phase wire the current flows to the through the fuse to the device, and through the neutral back to the transformer, thus completing a circuit. Now suppose there is a short between the heating element through which the current flows and the body of the heater. Okay, the body of the heater is insulated from is normally insulated from the conducting parts, uh, because it is the part where the human beings may touch. Okay, it is the part where we handle the heater. So it is necessary to safeguard this part from any accidental contact or short between the phase. Suppose there is a short between the phase and the body. You can see here I have indicated here a short. What happens is, you can see that the current flows uh, through this path instead of going through this path as before. Now it goes through this part mainly. Okay, maybe a little part may go here also, but now we are concerned about the current flowing through this path. You can see that the current flows from the phase to the fault point. This is called fault point, and from the fault point to the earth wire. The earth wire will be connected to the this part, this body, for protection. Okay, for passing this current to the earth like this. So the current flows from the body to the through the earth wire. It goes to the earth electrode at the site or at the house. Every house will have a earth electrode. And you may be aware that the earth is a good conductor of electricity, so the current will continue to flow even if there is no wire. It will continue to flow to the supply transformer. But you may note that this arrangement depends on the earthing system. Sometimes this earth wire may be continue up to the supply transformer. Such a system is called TNS system. This system, in this system, you can see the earth wire is terminated at the uh, this load side earth electrode, and it doesn't continue to a transformer. This system is called TT system. Okay, just these are some uh, extra points. The main point is the current will flow, continue, complete its path through the transformer through this path. Okay, and what happens is, assuming a sufficient amount of current flows, the fuse will blow, and thus this part will be isolated. So that means even if somebody touches also, there will be no, he will feel no shock because there is no supply reaching this point. But the condition for this is that the the current should be large enough to blow the fuse. If it is not large enough, what happens is, you can see here, there's a potential risk, the fuse doesn't blow. Actually, the blowing of fuse is a good thing. You must understand that, because it will not only isolate this part, this earthed part or grounded part, but it will also alert the people to a fault, to the presence of a fault. That means somebody can check here and rectify the problem. In case the fuse doesn't blow, this may happen if a sufficient amount of current doesn't flow through the this path because of high resistance in some area. Maybe there is a high resistance in this fault point. Okay, if the fault point is not a direct short, there may be a high resistance in this point, or there could be a high resistance in this point. Okay, this earth part, there could be high resistance. So if there is a high resistance in any of this path, what happens is a current flow will be very limited. It will not be sufficient to uh, you can say to blow this fuse. That means the system, this part, this fault point will remain live. That means it will be at the phase potential. Alright, now here lies the risk of electrocution. Suppose a person comes and touch this body of the heater. What happens? You can see that there exists a path, because this is live. There is a possibility that the current may flow through the body of the person, and through his body it may complete the path through the earth to the transformer. In this process he may feel a shock which can be fatal. But even here you can see that this earth wire does provide a protection, because the resistance of this part is very low compared to the resistance of the body. This will carry most of the current, but still it is desired to isolate this point by blowing this fuse, or by stopping the supply, to fully eliminate the risk of electrocution to the person handling this heater. As we have seen, this may not always happen, because depending on the earthing system and the fault point and other factors, there may not be enough current flowing in this path. This path is called earth fault loop. There may not be enough current in the earth fault loop uh, to activate or to isolate the supply by this fuse. Okay, because the fuse needs typically large amount of current to activate. So in this case, it is not practical to use fuse as a protection against electrocution. It is where the RCD comes into picture. RCD, as I said, stands for Residual Current Device. You can see the connection of RCD here. You can see the difference in connection between the fuse. Fuse, you can see it is connected only in the line, but you can see the RCD is connected to both line and neutral. Okay, you can see that L1, L2 is the point. L1 is the point where the incoming line connected. L2 is outgoing line connected. N1 is where the incoming neutral connected. N2 is where outgoing neutral connected to the heater. You can see an actual picture of RCD, and you can compare it with the circuit breaker, normal circuit breaker or fuse. You can see that the fuse, as I said, or the circuit breaker, a single pole circuit breaker, as I said, it has only two terminals, one for incoming line 1 and one for outgoing line. Here you can see for RCD there are you can see four terminals. One is for incoming line, this is for outgoing line, sorry, and this is for incoming neutral, and this is for outgoing neutral. Okay, you can see that both line and neutral needs to be connected to the RCD. Here I am focusing on the connection of RCD. I hope you connect this picture with our previous picture. You can see this is our previous picture, and this is the connection of RCD, L1, L2, N1, N2. Same thing is shown here, L1 and N1 as the input, L2 and N2 are the output. Okay, in this case what happens is the RCD, you can see this arrangement, RCD has an internal circuitry which compares the current in this two wires, that is line wire and neutral wire. You can see in the normal condition the current will flow through the load and through the neutral back to the supply. So that means if suppose there is no fault, there is no earth fault, that means there is no short through the wire, what happens is there will be no current here because there is no short like this. So you can see that in that case the line current will be similar or same as neutral current. But suppose there is a short between the line and neutral, what happens is some current will flow through the from the body, through the body it will flow through the earth wire to the earth. So in this case this RCD, as I said, has circuitry which compares the line current and neutral current, and in this case you can see the line current will be larger than neutral current because some current is lost through the earth wire. So this condition is sensed by the RCD, even with a great sensitivity. You can see that we can normally we use a sensitivity of 30 milliampere, because that means if the current that is flowing through the earth wire is greater than 30 milliampere, then it may potentially be harmful for a person, so that RCD will immediately trip the circuit. So that is how the RCD protects the people from electrocution. You can see that this RCD has a high sensitivity compared to fuse, because as I said the fuse needs a very large current uh, to operate, because that the current depends on many factors that is not controlled, that is not always controlled by us. For example, if the resistance in the path of the fuse is large, it is not activated, which may uh, pose the risk of electrocution. But in the case of RCD, we are feeding it with both line and neutral, and its only function is to compare the two currents. And if the currents are not same, it indicates a potential earth fault, and immediately the RCD will trip the circuit. One last thing to tell about RCDs, you can see that RCD has a test button, and it is very important to test the RCD from time to time to see that it is tripping. It will trip under an earth fault. So it is useful just to see about how this testing also work. You can see that the test circuit is like this. You can see that basically what when you press the test button, what happens is it is closing a path, it is shorting this line and neutral through a resistance. Okay, this resistance is used to limit the current to a safe value. So you can see that here what happens is the current is some current is bypassing the load, or it is shorted to the neutral outside the RCD. Okay, that means it is not detected by the RCD. So RCD, but it will detect the unbalance in the current flowing through line and neutral. And because there is a imbalance caused by the pressing of trip button, the RCD is supposed to trip. So this is the process of testing the RCD. Suppose the RCD doesn't trip even if you press the trip button, then it is necessary to replace that RCD, because then it may not, this RCD will not give protection even under a real fault. I hope you have followed my lecture, and if you have any comments, please let me know. Any doubts, you please let me know. I will try to answer. Thank you.